The inequality 6 times the quantity x plus 2 is greater than 7 times the quantity x minus 5. That is equivalent to which of these? Well, we're going to solve this inequality as these are solved for x. And to solve an inequality, it's just like solving an equation except for a couple of rules here and there. 6 times quantity x plus 2, we're going to use the distributive property. The 6, take 6 times x, that is 6x, and 6 times 2 would be 12. Then distribute the 7 through the second set of parentheses there. 7 times x is 7x, and 7 times negative 5, watch your signs, it's negative 35. You need to get the x's to one side, everything else to the other side. And you can do it however you want. You can do any of four things here. You could subtract 6x, subtract 12, subtract 7x, or add 35. You could do the opposite of any of those four things showing. I'm going to subtract 7x and also subtract 12. So I'm moving the x's to the left side, moving the constant terms, the terms without variables, to the right side. So if I subtract 7x from each side, on the left I get negative x, and on the right that is negative 35 minus 12 is negative 47. So we have negative x is greater than negative 47. Now here's the one rule you have to be careful of when you are solving inequalities. Whenever you multiply or divide both sides of the inequality by a negative number, you have to change or flip the inequality sign. Once again, whenever you multiply or divide by a negative number, change or flip or reverse the inequality sign. So that greater than sign is going to become less than when we divide by negative 1. So if you divide each side by negative 1, negative x divided by negative 1, that is positive x, and negative 47 divided by negative 1 is positive 47. But we also change the inequality sign to be x is less than 47, letter E. Sides of a square are 3 centimeters long. One vertex of the square is at coordinates 2, 0 on a square coordinate grid marked in centimeter units. Which of the following points could also be a vertex of the square? Well, if the sides are 3 centimeters long and one point is at 2, 0, then go 3 in each direction. The x coordinates, the y coordinates, go 3 in each direction, and maybe you can find another point. So if you go 3 to the right of 2, 0, that's going to put you at 5, 0. So I'm telling you right now that the answer is K. So that's one way to look at it, is if the x coordinates have a difference of 3, the sides are 3 centimeters, one point is at 2, 0, another point would be at 5, 0. Just to verify that, you could put those points on a graph, starting with F at negative 4, 0, G at 0, 1, H at 1, negative 1, J at 4, 1, and then K at 5, 0. And with your point, your home point being at 2, 0, you can see that 5, 0 is 3 away. So the answer is letter K, 5, 0. For triangle FGH shown below, which of the following is an expression for y in terms of x? When it says expression for y in terms of x, that means you're solving this for y. It's going to be y equals, and then everything else is going to be the other side, including the x. First thing I think of when I look at this is the Pythagorean theorem. Pythagorean theorem states that the sum of the squares of the two legs is equal to the square of the hypotenuse. If you aren't familiar with the Pythagorean theorem, the hypotenuse is the side across from the right angle. The other two sides are the legs of the triangle. So you could say that x squared plus 4 squared is equal to y squared. Or you could even say 4 squared plus x squared equals y squared. Doesn't matter what order the x squared and the 4 squared are in. But that is equal to the y squared, the hypotenuse squared. So solving this for y, we have this 4 squared to deal with. You need to square, that's going to be 16. So it'd be x squared plus 16 equals y squared. And then to finish solving that for y, you have to undo the squared. So to undo that, or do the opposite of that, you're taking the square root of each side. When you take the square root of each side, it's going to be y equals the square root of x squared plus 16, which is letter E. A bag contains 12 red marbles, 5 yellow marbles, and 15 green marbles. How many additional red marbles must be added to the 32 marbles that are already in the bag to create a probability of drawing a red marble out to be 3/5? Well, meaning of probability is the number of successes over the number of possibilities. You think of flipping a coin, the probability of getting tails would be 1 out of 2 because there is 1 tails and 2 possibilities or 2 choices on a coin. So the probability is number of successes over number of possibilities. For this right now, the probability of drawing a red out would be 12 because there are 12 reds right now out of 32. There are 32 total. So 12 out of 32 right now without adding any, that's the probability of drawing a red out. The question is adding which of these amounts to the reds in the bag will create a probability of 3/5. Well, one little thing to think about here is that since that denominator is 5, the amount that you add will create a total that is divisible by 5 when you add it. So if you look at those last two, if you added 32 onto the total, 32 and 32, that would make 64. It's not divisible by 5, so it's not going to work here. And then the 40, if you add 40 onto that, 40 and 32 is 72. That's not divisible by 5, so it's not going to reduce to 3/5. So J and K are out right now. It's either going to be F, G, or H. So I would go through and I'd just try each one of those. Add 13 onto the red and 13 onto the total and see if it reduces to this 3/5. So if you add 13 onto the red, that's going to be 25. Add 13 onto the total, that's 45. Question is, does that reduce to 3/5? No, it doesn't. 25 out of 45, that reduces to 5/9. So it's not F. Try G, 18. If you add 18 onto the red and 18 onto the total, 18 added onto the red, it's going to be 30. 18 added on the total will be 50. Does that reduce to 3/5? Here's simple reducing. Just cancel the zeros off. That will reduce to 3/5. So letter G, 18, is the amount of red that you're adding to the bag to create a probability of 3/5 when you draw it out.